Okay, so we're gonna get started in a minute. Meanwhile, I could post to the chat. Okay, so the topic is already set to the old notes of the previous meeting, but I posted to the chat a link to the meeting minutes of this current Wishy session. So you can go ahead there and feel free to join collaborative editing for the notes. Okay, and now I see we have. Okay, and we can hear you, Petri. Audio check successful. So I see we have at least most of the people who we are expecting. I think Michael Koster is still probably joining.
So
but
what
maybe
is
we
the
can.
lobby?
Sorry?
What is the lobby? Logan just mentioned that Jerry is in the lobby.
I guess Mythico doesn't have a lobby.
Lobby?
Sorry, Logan, I didn't quite hear what you said.
Oh, I just was pinging with Jerry, and he got he basically got a pop-up saying that he's in the lobby waiting to be let in.
Oh.
Is there not a lobby for the room?
That's more of a Microsoft term.
Huh.
He might be in the wrong meeting. Because as far as I know, Mythico doesn't have a lobby. I think WebEx and Teams have lobbies.
Okay.
But if you can send him the link that you used to follow, because you made it here successfully.
Yeah, I'll get him the link.
Very good. Thanks a lot, Logan. Okay, so meanwhile, let's get started. So welcome everyone for the next Wishy call, the one before summer vacations and the following IETF meeting. We have on agenda today 3 main items. The plan was to start with an update on the IoT standard description from Milan. There is a Thinking RG draft in progress on that. I'll have a quick discussion on the status and the way forward. The second main topic of the day would be data model versioning. So that's an activity we have started already quite some time ago when we did some work on the previous Wishy call. So Karsten will be giving an update on that. And then finally, maybe the most substantial item we have planned for today is this work on SDF extensions for relations and links. So this is a bigger work item that we have been kind of discussing around on the SDF work, but while the SDF work has been very much focusing on finalizing the upcoming RFC, these links and relations have been something kind of for future work. So that's why we have been discussing these items in the Wishy group. And there we have some recent development. Petri Lari submitted a new draft on that. Michael Koster has been doing quite a bit of work on that topic. So we'll have Karsten and I, so we could have a discussion around that and the way forward. How do we make these extensions for link and relation information? So that's the draft agenda for today. Any requests for updates or new agenda items or any questions or comments?
Yeah, I think it would be best if I can show my slides on links first. Just a couple of slides that kind of structure the field, and then we can leave the details to the other presenters.
Sounds like a good plan. Okay, thanks, Karsten. So if there's no more questions or comments, I remember Marie Jose was planning to join, and she was actually interested on the first 2 agenda items. So what I think was in particular I'm interested on the first agenda item. So what I maybe would suggest, if we start with the data model versioning and then we go to IoT standards description, would that be okay for you, Milan and Karsten?
Fine with me.
Sure.
Brief update
Okay.
anyway.
Okay. Good. Then let's do it in that order. So, Karsten, please go ahead.
Okay, I will start with a very beautiful set of slides that you can see on your screens. And if you actually want to see more, then you have to go to the top left corner where you see a loop, and you can click on the loop, and then you see the slide. I mean, it's not really a slide, it's just the wiki page, and you can scroll through that and see what I'm talking about. So the idea was that we were going to start a wiki page about versioning, just collecting links to various places. So the links we have at the start are slides from various wiki calls, and these slides may be a couple of years old already, but they do show a number of considerations that went into this work that aren't too much outdated yet. So I would start with that. And then there are several items under which there are very brief notes that we probably have to expand to turn this into a document at some point. But right now we just do it at the wiki level. And there are, first of all, a set of reasons for versioning. So why would you even want to do versioning? What's the need? So this is about versioning of the data models. Of course, there are other things that we may want to version at some point in time. We have been informally versioning SDF in various forms. But of course, once this is an RFC, we will have a stable base version and work from there. So, for instance, the requirements for models might change. Assume that there is some new regulation going in effect in the EU that requires all IoT refrigerator to do something specific. Then you need to put this into the models for a refrigerator, and then you have to be able to create a new version of the model or a new model. That's really just the same thing with a big difference. So that's one of the considerations we have to think about. Then, of course, there can be errors in the original models, and there can be a need to merge models from different sources. So the next point we have to think about is compatibility. We often are using the terms backward and forward compatibility, and almost always we are using those terms wrong. So this is one attempt at actually writing down the definition of backward and forward compatibility. And clearly we have to refine that. But I think it's really important to think about those two aspects separately from each other, as much as they can be separated, of course. Because sometimes one is absolutely crucial and the other one is a nice to have. So that's worth separating those. Yeah, and compatibility is just the special case of a specific aspect of interoperability. So interoperability is, of course, an important consideration. And one consideration that's sometimes a little bit counterintuitive is that you actually want to prevent interoperability in cases where the interoperability would lead to the wrong result. So if you have a refrigerator and a freezer, and you are applying a command to the refrigerator that really only makes sense for a freezer, then something weird is going to happen, and you don't want that to be possible. So you have to limit interoperability. But of course, except from when you actually need to do that, you want to get as much interoperability as possible. So from there we come to the question, what are we actually versioning? Because much of our intuition about versioning is based on versioning software. And there is a really, really big difference between versioning a single software product that is under control of a single entity, and a protocol which is always an agreement of two or more entities. And therefore, the meaning of a version for software is not the same as the meaning of a version for protocols. And that's why we sometimes have problems with trying to import concepts like semantic versioning and so on, because you really have to adapt that. Okay, so this is notes we have copied from previous discussions, and the point today was mainly to point to this document and maybe get some discussion going here on the wiki page by adding stuff, or on the mailing list if there really needs to be a discussion before we can add things. And we want to develop this in such a way that we understand that data model versioning enough to address this in the next version of SDF. Any questions about that?
And Carsten, is there a notion of simple replacement? If there is no installed base and you're changing the model, it might be, rather than proliferating deprecated versions, simply, drop the previous, basically replace the previous one. And
yeah, that would be another case of preventing interoperability. Yeah, that's definitely a good point. Because backward compatibility can be a really big piece of baggage, and you need to think about how much of that baggage you actually need to carry around. Good point.
Yeah.
So I hope that's in the notes, so I know what to copy over when this meeting is done.
Yes, I hope I captured it correctly. So
thank you.
Please go check it out. Okay, thank you. Any more questions or comments on this work?
Yeah, I have a question, and a more general question. Carsten, I took the agenda item to mean in general consideration of things that we may want to record on wiki site. And I don't know if there is a place to try to put the definitions, as we were discussing recently, of edge and, let's say, of digital twins, to at least to put a few paragraphs together as a consensus of our current understanding of what those things mean, so as to improve the understanding and hopefully consistency in using the terms. Or is that anyway, is that worthwhile having something like that for a few select terms on the wiki?
Absolutely. There actually even is a page, the Glossary of Terms. I don't know if that is the kind of page you are looking for, or whether you want to have a more in-depth, more formal definition.
Well, it depends. If we agree on the definition, then it's fine. But if we have to debate it, maybe we, have a separate page to chisel it out.
Yeah, maybe we can start in the Glossary of Terms, and I just see that the most recent advances we have had on the definition of things and related terms is not yet on the page either. So maybe that's a good point, that we should work on that page a bit as well. Thank you, Milan.
Very good, thanks. And Karsten, can you post links to the right wiki pages in the chat, perhaps?
Yes.
While I'm taking. Very good. Thanks a lot.
Something is very weird with a Jabber. I hope I can do this in the Zulip thing. So does this work?
Or at least the Mitico chat tool.
Yeah. Let me try if that works. Something is weird here. No, Zulip does not work. But the Meet Echo chat works and actually copies over to the other one. Okay.
Excellent. Okay. So I guess the next steps here would be to continue the discussion on the wiki page, both on this specific one, but then also on the glossary of terms as we discussed, and then later on turn these into a RG documents that will get a wider view and consensus on. Okay, thank you. Any final questions, comments before we go for the next item? Okay, in that case, I'll grant Milan the sharing. Yes. There you go. Go ahead, Milan. And we don't hear you, Milan. We hear some sound from you, but not your voice. Or does someone else hear Milan now?
Okay, now?
Yes.
Now we can hear you. Thank you.
He muted me when I was sharing the slides. I guess that's the side benefit. Anyway, I have a pre-publication version as far as I'm concerned. Basically, I massaged the paper. I mean, included some edits that I got from you, Ari, and a few others. And as far as I'm concerned, it's ready to publish. I posted it on both the XML and PDF versions on the wiki on this zone that Karsten created. So if somebody wants to look at it's on the GitHub. And the document title, this morning I had a coffee thought. The official title of the paper, in the paper itself, it says IoT Information Model Standards Description and Nutrition Label, in parentheses to indicate that it basically wants to have a conformant or commonly understood definition. I was thinking of maybe calling it the normalized IoT information model, but that sounds too formal, which it's not. So I think we'll stick, unless people tell me otherwise, with the version that it currently is. I have also changed the file name because that's what shows up when it's posted. And it's now draft T2TRG IoT standards description version 00. And as I said, I ran the checks, the needs and stuff like that. So as far as I'm concerned, it's ready to submit pending the approval of the group today.
Okay, thanks, Milan. Yeah, so I had earlier, as we discussed, a quick read at the document. I think this would be, in my opinion, ready to be published as a 00. So
yeah. So fine. I incorporated that, and that's what the file name is now, as it's posted and as I was going to submit.
So maybe a question the group has, well, I guess many of you have not seen the document since it's not in the data tracker yet. But if you had a chance to look at the GitHub version, Do you have any comments on anything to be tweaked or adjusted before we publish the 0.0 version? And actually, Milan, now I realized one small thing on the draft name, since this is still an individual version, not a research group adopted version. You could add after draft, your own last name.
Yeah, there I wasn't sure whether it's supposed to relate to a person or simply to the topic of the thing. I mean, it could be done either way. Fine.
It's customary that the individual submissions that are not yet adopted as a research group documents, they have the lead author's last name. So
okay, fine. I'll add
draft,
that. I'll modify that.
yeah. So we can put
I was trying to
draft.
be modest. Yeah. Okay.
Yeah, I mean it's just a IETF tradition. So yeah, draft last name and then the rest
and
of
the
it
rest
can be as such. But it's good to have the TinyTing there so that it goes to the right places in the data tracker.
Yeah, but it's abbreviated. The name is IoT Standards Description. It's not the actual full title of the thing, but that's okay because
yes,
it's,
exactly. The short name is good for the file name.
Yeah.
Okay, but seems we don't have Mari Jose still, so I guess we'll get her comments offline, and we can point to the draft when you have it in the data tracker.
Yeah, I will. Should be later today.
Okay, great. Anyone else? Any questions or comments here on the standards draft? Okay, here in none, then I think we have a good amount of time for the final topic. So thanks a lot, Milan. Yeah, please submit the draft. If you want, you can check with the file name and those issues with me offline. But yeah, once you have submitted draft, you get the notification to your email about the submission. Then you can forward that notification to the RG list and say, like, give a bit of background, what is this draft for, and ask for comments and feedback in the RG list. I think that's the right way forward.
To the group, okay? Fine.
Okay, thanks. Then maybe we'll go for the final agenda item. So describing rich relation between SDF and other definitions and linking. Karsten, you had something you could show in the beginning to initiate the discussion. And your slides should be coming up. Now we can see them. Yep. Please go ahead.
Okay, so I just wanted to do a little bit of terminology first, because we have been talking about links in a number of different contexts in data modeling and interaction modeling. And just as a reminder what the link is, a link is a statement in three parts: a subject, a predicate, and an object. So a link points from something that is here, from the point where the link points from, which is either implicit or made explicit by using an anchor, to there. And the there is a target, and the object of the link. And the predicate of the link is the link relation. So it says what the relationship between the subject and the object is. And typically, we also can attach target attributes to a link, so we can say a little bit more about what that is that you will actually reach when following that link. So you might have several links that just differ in their content format or something like that. So you could use those target attributes to find out which link you actually want to follow. So that's a general observation about links, and links have been in use in this way for a quarter century now and more. So none of this is new. And there actually is a standard RFC 8288 that we're using, which is called web linking, that is underlying much of what we are doing with links in data formats. So within SDF, within the data model environment, we can see three different areas of applications of links. The first one is one where we use links to construct our models. So the links are internal to our models, or they are used for inclusion by reference of models that are externally, but by actually acting on the link, also become part of the overall model that we are talking about. So in SDF right now, we have two forms of that, and I'm pretty sure we need more forms, but that's what we have. We have inclusion by reference, and I should have said syntactic inclusion by reference, because that's really what we have right now. There might be other forms of inclusion. The SDF ref quality, and we also use links for internal pointers within the model tree, where we have, for instance, SDF required. Petri, are you trying to say something?
Sorry, no, I have these problems with this Metico again, with audio.
Okay, but we can hear you well. Can you hear us?
That's perfect. But I can I didn't have any questions. I was trying to get the audio to work, and
it seems to work now.
At least.
Great. Okay, so that's one kind of link, where the fact that we are using a link is just a way we bring together the various parts of the model, or how we talk about one part of a model in another part of a model. So right now we have SDF required as the only form of an internal pointer. We used to have more of those, but we were able to get rid of that. But of course, the way, for instance, we include data models using SDF ref could also be done in a semantic way. It wouldn't need to be in the syntactic way it is done right now. So that's one thing where essentially the actual set of things out there that are described by this model don't notice any of this going on. It's just the internal glue of the model. The second kind of link that we are using are pointers to vocabularies, or to actually specific terms out of vocabularies. So we have discussed whether we can use links as quality names, which is one way of using links in place of existing vocabulary. And of course, we need to be able to use links as data values. So for instance, when we want to reference some semantic category, for instance, a well-defined unit out of one of the measurement unit ontologies, or some other kinds of enums, that is often best done by a link to that other ontology. So enums can, of course, be just strings, or they can be referenced to something that is in the link space, something that becomes a referenceable identifier that way. So you actually can follow the link. You don't follow it in the normal course of things. But if you're building software that uses such an identifier, you may want to reference it to pull some information about those identifiers. And general semantic links, things that we would be doing in RDF, these are also related to these links that really use vocabularies. So here links are really just the URI that we are using. We're using the URI as a name or as a referenceable identifier. This is visible to the thing. So if you have a calibrated thermometer that is telling you that works in the 1990 temperature scale, that's something that the thermometer is going to tell you. But the things don't actually follow these links. The links are just identifiers. And the third kind of link are the ones where we really use those links as instance data. So you might point to an instance that is another thing, or the affordance of a thing. So you might be able to point into a thing in some way. You might be interchanging these links, and of course you might still be using some vocabulary while doing that. So for instance, you might have a link to a thing, but then you have a fragment identifier that actually is taken from a vocabulary. So there may even be some construction or parsing of these links. So this is looking at the links themselves. Then of course the next question is, how do we actually model these links? So what language elements do we have so we can say which of these links are present or need to be present, what needs to be filled in, what maybe also can be left optional. So for the links that are used in model construction, there is no need to model the model here. There might be some mechanisms like generics or constructors that do add some modeling there, but as a first approximation, we can just use links like that in the models like we are using SDF-Ref and SDF-Require today. Links in model vocabularies, of course, do ask the question, which of these vocabularies actually are useful? So if I'm describing a refrigerator, and I'm describing that with terms like electricity driven and gas driven, and then add a third term that is about some soft cheese, that vocabulary doesn't make sense in this context. So we may be able to provide some data typing in some form. For instance, based on RDF is something that allows us to constrain and describe what these model vocabularies actually do. And finally, we have links in instance data, again, where we really want to model what kind of link this is. And again, if you have a refrigerator, it really doesn't make a lot of sense to use a link that is meant to pair it with a freezer to instead connect it to the garden hose or something. So again, we probably need some type information here. And so this may just be data, or it may be actions, or it may be entire things or SDF objects. So that's something we have to think about. Of course, we can start out with a situation where this is all typeless, but probably at some point we want to model that as well. Okay, and of course, it now becomes interesting when we think about the fact that SDF really was designed to enable translation. So you have some ecosystem-specific model information, and you want to be able to translate this into model information at the SDF level. So this means you need to be able to translate back and forth. And of course, every ecosystem environment has their own form to talk about links. So we know how IPSO does this and so on. So there are several things we need to do here. And one is about the SDF model itself, but we also need to think about the mapping files, which actually add information to a generic model, and where we therefore also need to think about transforming information. So the slide gives some examples here, but maybe these are not the best examples, but we just have to think about how this modeling information can be useful in a transformation setting. Okay, so that's essentially what I wanted to point out. And of course, at some point, we will need to understand the processing model that we are using for actually operating on these links. We need to have good examples for the various cases and how they differ, or how they actually may be similar in some cases. And we need to use these to actually understand what needs to be in the model or in the meta model. So what are we making possible to put into the model? That's the meta model. So we can evolve this into something that is can be used in a good way. Okay, questions about that? Maybe this was all trivial and everybody knew that already.
No, thanks, Karsten. I think it's very good that we have a, as you said, like shared vocabulary when we talk about these things. It's easy to talk past each other, as we have seen before. So, okay. So I guess with that introduction, perhaps what we could do is have a look at a specific proposal around these links, and in particular the ones that are referring to definition, other SDF definitions and external ontologies. So, Petri, I can share some slides and give you control.
Yep, back online again. I hope you hear me.
Yes, we can hear you now. Let's see if the slides arrive. Okay, let me try again. Okay, now you should have the slides visible and the slide control a minute ago.
Well, I see the slides.
Oh yeah. Perfect, it works because I have this audio button in the middle of my screen, but it seems that I can change the slides. Perfect. Okay, so let's go here. So we have been working with this SDF relation extension to this SDF, And basically, we have been working with the DTDL relationship and trying to make that kind of similar mapping to SDF. So there's mostly everything is related to DTDL relationship in our work. And for the future, we have to think about also other possible ecosystems and how the relations are defined there. But let's say that this is like a starting point for that work. The draft has one initial design, and there are quite many different kinds of ways to use the relation or define it in the class level. And one thing here that came up was that, okay, so basically we want to do a class level design on that, but in some sense it can even be thought about instance, so it must be something between maybe class, kind, type, instance. There, it's somewhere in the between, possibly. This is the current design that we have there. So it's a pretty simple. So we have the namespace, external namespaces. We have here now 2 examples. Then we have an SDF object, which here is the temperature sensor. It has some properties with SDF property. And then we have the SDF relation field here. So in the first, we name it as same as, and basically defines that the relation type it's a same type as something else. And here we make the target to another ontology where we have this temperature sensor defined. So basically we have similar setup here in this system. And the second relation we have, it's contained in. So basically the type is contained in, and the target is the room. So we can define different kinds of systems, and then we could have, for example, the thermostat that is controlled by this temperature sensor. So that is the basic design. We have defined here the SDF qualities. We have relation type, what kind of relation we have. Then we have a target, and that is the target to which we refer to. We have description field, gives the basic description of that relation. We have taken here max items and min items, which are defined in the DTDL. Properties, we can have different kinds of properties in the SDF relation, and then also we have this writable or just readable property. On the following slide, we have the basically direct mappings to the DTDL relationships. What we have this SDF relation, it's defined in DTDL with the type, what kind of, or in DTDL relationship, this must be relationship, the type. Then the DTDL has a specific field name, giving the entity name, and it's a one field in the SDF, or the first name field in the SDF relation. Relation type, what kind of relation, writable are directly, target directly, comment directly. Then we have description, which is the same in both. DTDL has this display name, which is not defined in SDF. Also that DTDL has this low. Sure.
Quick question, why not did you guys explicitly chose to avoid it? It's quite common in standards like haystacks and the other, just for convenient of managing basically operators consoles, to use the familiar names or the names that they can define that the standard otherwise ignores. It basically, the system doesn't interpret. So is there a particular reason you chose not to have that in
display name?
Yeah,
you mean?
Something to that effect, that is basically not interpreted by the system, but can be shown on the management console, or on the display on basically visualization system.
I don't mind adding it, but the SDF doesn't currently define it, so that's why it's not described here. Possibly it can be added.
Yeah, it might be useful
And
to consider.
also the other,
yeah.
the other thing is that the DTDL defines this localizable description and name, which is not defined in SDF, so that we could have multiple languages there also.
Yeah, I think perhaps the key thing here would be how do we handle internationalization in SDF? Because I guess that's something we haven't designed yet, and I guess once we do that, then whether it's a new quality or it's a different way to use the existing qualities, probably would be the way to go. But I guess that's let's say full SDF level discussion and not just for the relationship. But good point, Milo.
Yeah, not only for this draft. Then we have properties that can be defined as SDF property. The one thing that came out here is that there was not examples or any existing DTDL files that could have been used so that we could have made better mapping and testing it, how it actually works, unfortunately. But anyway, this is quite direct mapping between the SDF quality and DTDL qualities. But that was the basic design, what we have been doing here. So it's a relatively short draft. But then we have this SDF relation can be defined different ways. So, and we had some alternatives also during the work. And one interesting that came up at the last minute was how about defining the relation as in this presented example. So we have SDF thing, which contains two SDF objects, robot arm A and arm B. And then we have a separate SDF relation entity defining AB and BC connections as bidirectional next to each other. This is in conceptual way, this is a little bit different than what the SDF is usually using, but it has, I guess, pros and cons and how to do it. But I guess the most important thing would be to get the input. How do you people see what kind of, how we should define the relation? So basically we have one alternative now in the draft, and is it okay or not? What should be fixed and so on. So thanks. This was my very short presentation on this.
Thanks, Petri. And I see Michael Koster in the queue. Go ahead, Michael.
Oh, thank you.
Now we hear you.
Yeah,
Yes,
yeah. I've been really have a couple of different use cases for this sort of thing, and I've basically done a couple of implementations. So sort of looking at the processing model and where it fits in the workflow. And most recently, I basically looked at this draft and modeled a thing after this pattern. So I would say that the two things about the draft. One is it sort of aligns pretty well with the general model we all understand for links that Karsten articulated earlier, which is there's a anchor and a target, or source and destination, subject and object, and then there's a predicate that consists of a relation. And then additionally, there's target attributes. I think that the latest link draft actually says, well, these might be called link attributes also, sort of I'd say a nod to the emerging idea of property graphs that we have. And so to the idea of stacking values on the link to represent target attributes, or whatever have you. I think there should be a general solution for that. I see that pattern in the draft as being a pretty comprehensive general solution for linking. And the example that I wanted to do is create a sort of an object model ontology using SDF, where you define objects and the properties they have, and then the way that they relate to other objects. And I have an example of that. But it basically, to summarize, it worked out pretty well. So I would say that I'm definitely in favor of what's in there. I've changed my example link value, but also target attributes or link attributes. If we wanted to align with the terminology in the link draft, I think that would be okay. It would mean the same thing. It would just have a different name that would be more aligned with the web linking. I think it does make sense to align with web linking, especially that it sort of seems to support everything. And I had another use case for linking as well, but maybe I'm going to talk about that a little bit later. But basically, the thing that I'm interested in SDF for is constructing models of systems. And so when we say instance, this might really be a template that we're creating that has all of the sort of the resolution of an instance. But so I think it's an important thing to add to the use case, to add SDF to SDF flat linking that isn't hierarchical and implied. And I think Karsten's presentation sort of hinted at that, but it didn't quite call it out. And so I have some of that. Anyway, I don't know how much time we have. I'd like other people to be able to make comments, and I have some material I'd like to share as well. But I think other people's comments and impressions are more important. So I think we only have a few minutes left. Anyway, those are my comments. Thank you.
Thanks, Michael. And actually, we booked 90 minutes for this session altogether, so we actually have a fair amount of time for this topic. One question, when you meant about the flat linking, did you mean like linking capabilities beyond hierarchy, or did you mean something else?
That's several seconds long. So the use case I have is to basically construct a model of a system that's constructed of things that are defined by SDF objects and SDF things. And I don't always want to just have a thing that encloses objects in bigger and bigger things until I have a system thing that encloses the subsystem things and all that through SDF ref. There's too many layers of inheritance in the model, right? Everyone would agree with that as the model gets to some level of complexity. And I don't think we should really limit the level of complexity that SDF provides for. So I think it's important to be able to say, here are my building blocks for system models. And at different times, I have one level, which is a sort of a Node-RED flow graph type thing that runs on microcontrollers, where the objects are like little IPSO objects that are things like sensor readers and unit formatters and publishers and subscribers and things that you can create a little graph. And that's a system model. And another system model is maybe a digital twin where you have actual pieces of the system. And so what I've done is I've modeled the pieces of the system using SDF models. And then as you can just refine those by applying constant and sort of doing things that resolve all of the open definitions, and you can have a type number and constant 3 or whatever there, So you can basically have an SDF model, but what you need to do is be able to say this model connects to this other model in some particular way. This object connects to this other object in this case. So you might want to say that this thing is part of another thing using a semantic link as opposed to making it part of it using STF ref, and so you can have a more loosely coupled sort of relationship that still implies some kind of, or you can say this thing is connected to this other thing, or you could say this this object acts on some properties on this other object. So basically what I'm saying is you make an RDF-like graph, but basically is how you construct the system. And then when you go to make an implementation of the system, whether you're running it out in Python code or C++ or, a database schema where you're going to make rows of a data in a database to represent all this stuff, or a graph database where you're going to make nodes, etc. Right? So however you're going to implement it, the system model has all the information you need in SDF to implement it. So use all the SDF tools to sort of take all these linkages and do whatever you need to in the target system. In my target system, I use lightweight M2M objects. And so the target system just uses an object link to connect one to the other. And then the objects are so simply designed that they know what to do when they're linked, to another object in a certain way. And so it's sort of, but basically there's an SDF model that has regular SDF links. And I used an extension, but I think you could certainly use SDF relation. I'm going to refactor my thing and use SDF relation once we decide what it looks like. And then you basically implement each object, and then the linkages you implement with the thing in the target system. So in a database, it would be a foreign key or a table that would join two different rows of different tables or whatever, et cetera, right? And so I think it's want to use SDF relation just to point to From my context, is what I want out of linkage is the ability to model complex systems at a number of levels. I want one level to be the SDF graph, and SDF to then assemble those models, and into larger things. And maybe sometimes I'm just going to have an SDF thing that has, one or two properties and a bunch of links to other things. We talk about these patterns, but in an ontology, sometimes you do have a thing that represents the floor of a building that basically is mostly how the different zones are connected, and it's more than, it doesn't really say much about it. It's just how the zones connect and what the surfaces look like and how the surfaces connect to each other. But those are all described in other pieces of the model. The model of the floor is mainly just a thing that holds other things like a container. And so I want to be able to build models like that using SDF. That's what I mean. So it isn't always flat like that, but it's using relations to imply the membership and the connectivity and the directionality and things like that.
Yep. Okay. So what I'm hearing, what you're saying is that, we need this kind of capability where we can define relations beyond the simple hierarchy that we can do with SDF today. And then there are a lot of nuances there, like what are you actually modeling, if it's kind of semantic relation or something else. And I guess that's the kind of interesting part. Like, do we use SDF relation, kind of this, let's say, whatever we shall call the keyword? Do we use the same thing for all of these use cases, or is there need for multiple different kind of links? Like going back to what Carsten pointed out, like in terminology, should the instance links, instances of data, should that use the same construct or not? And to be honest, I don't have a good answer yet. So of course I see, for the instance of data, I see two different methods to model that. One would be something like a property that you can read and write runtime, or another one would be basically using a property, using a new property type link. The alternative would be something like a new keyword. It could be SDF relation, could be SDF link. And which one makes more sense? That's something I haven't quite figured out yet. So, Carsten, what are you thinking?
Yeah, I think it's really important to when we build these examples, that we not just build examples that look pretty but that we actually have a processing model, how that information is actually going to be used. So for instance, if I define a light switch, and that light switch has the ability to be paired with a specific light that it is switching, then among the instance data, among the properties that define the light switch, there will be a link to the light. And there are several aspects of describing that. First of all, there is a property. This property has a name. This property has writability, and maybe if we add security stuff or authorization stuff later, it will have some authorization mechanisms to it, and so on. And the other part is that the value of that property actually is meant to lead to the affordances of the light. So again, bringing the light switch together with a garden hose may be very funny, but it may not be the kind of value you want the property of that light switch to take on. So there is a description of the data type that this property actually can take on that includes information about the target of that link. So we have the modeling of the property that tells us how do we set this stuff, and we also have the modeling of the data that tells us so what do we set here. And the third thing, of course, is trying to explain now that the light switch actually has that link, what does it actually mean? So is the light switch going to do anything with that link, or is it just stored there in a property for somebody else to do something with that link? So that also needs to be described. So if we have some on-off mechanism as part of that light switch, we may want to, now I'm missing a word, link that to that link. So to make sure, well, okay, the light switch has 3 different knobs you can press, and the second of the knobs, that is actually going to that light over there. I think it really makes sense to think about these various aspects of the modeling separately and make sure we have ways to express all of them. So if I look at the example that's on the screen right now, what this tells me, if I translate this into 8288 web linking, so this would be a bidirectional link. These do not exist, but that's not a problem. I mean, we can always invent that. So the type really would be the link relation, and party 1 would be the anchor, and party 2 would be the target. So that's again something that can be easily described. But how you actually make use of that next to relationship, that's really not discussed in this model. So you need to understand next relationships to actually learn something from this that you probably then can use in your real world modeling of the 2 arms. But that is not creating or modifying an affordance of the digital side of that arm. The fact that they are physically next to each other has no bearing on what you actually can do with these things. Or maybe it does, but that would have to be defined. So, of course, the underlying question behind this slide 6 is what other kinds of physical properties can we describe that maybe doesn't have anything to do with links at all. So I have elevation or something that I can describe for something that doesn't need a link, but it's of the same kind of information that the relations on this page have.
Yes, actually, that elevation is kind of an interesting example, because I guess you could easily define that with this kind of construct, that like the type of the link would, I mean, maybe the current slide is actually a bad example. Petri, can you flip an example, earlier example? Because this is showing.
Yeah, that was
Yes.
not even following the terminology.
Yep. So maybe this is a better example. So let's say the elevation you would do relation type would be basically a term in some ontology called elevation, and the target would be just a raw value. That could be one, I mean, RDF-ish way to describe that kind of thing. Or is that anything along the lines what you were thinking, Karsten?
Can you say that again? What is like what
So,
I'm thinking?
So if you think about the elevation example you had, that if you would need to let's say, I assume that your example was of the elevation of a, a device would be, X meters.
Yes.
So you could, one way to express that would be a STF relation called elevation. The relation type would be a term in an ontology that is about elevation, and the target would actually, instead of being another definition, just a raw value, 42. Is that something what you were discussing, or is it completely different?
That's kind of orthogonal. I mean, we already have units, and we could use the term meter, and so we actually can describe elevations without a link.
Mm-hmm. Yep.
The point is that there may be some information about the environment that you may want to know or need to know. For instance, if that thing is boiling something, then you need to be able to infer the boiling temperature. And there may be information in there that you want to describe that is of the same general kind, where the information doesn't describe an affordance. That's all we can do in STF right now, describe affordances. But it's actually describing a property that is modulating all these affordances, but it's not really changing anything what you can do with your water kettle. You can boil water, but the knobs don't change when you use it at different elevations.
Indeed, and I think because I guess there are so many different ways to use links, we probably do advanced discuss, so we need to focus on a specific case to begin with. So what I'm thinking, what we could perhaps focus for a while, is this be the fact that what I'm thinking is probably closest thing that, for example, Logan and Jerry need, based on the discussions we had earlier, is this having let's say more semantic information on those definitions, whether it's affordance or thing or an object, and being able to say, for example, that hey, this this object is kind of the same thing as this temperature sensor in that ontology, and that's kind of what the same as relation is here trying to express. So maybe the question would be for everyone, like, is that something reasonable way to express that kind of information, or is something completely different better or more useful?
Well, what's written down on this page 3 is a relation from the object to two ontology entries. So one is the object is the same as the concept of a temperature sensor, which is a bit weird, but maybe you actually mean that. And the other one is the object is contained in the concept of a room, which also is not very clear to me. I mean, usually things are contained in specific rooms and not in the concept of a room.
So basically, this is like this. Okay, this specific temperature sensor can be contained only in a room, nowhere else, and the sorry, the instance information would be that okay, it's in room 315. So
yeah, but that is not being modeled here. The only
no,
thing,
not the instance.
the only thing you're modeling here is that, okay. Yeah, but I think we need to be able to model the other thing as well. So I think we actually have to make examples that actually expose these differences between talking about concepts and talking about specific instances of that context.
Yeah, I agree. We eventually need both. I guess the approach here was to focus on the class level information so that we don't have to go to that discussion yet. How do we name the instances? Because that's another interesting discussion to have. But maybe we need, as you said, both quite early to have a good design for both styles. But actually, maybe it's as Jerry, actually, I saw you wrote on the chat to kind of start with a motivating use case. Maybe that kind of approach is here also useful, and maybe, for example, look at one of the use cases that you have. We could see like if we can model those use cases with the right kind of information here. So do you want to have your start? Thanks.
Definitely, I'd be happy to. So first of all, I want to draw the group's attention to a comment that I put into the window saying that well, for example, I'm having a hard time following it. It might be because I'm new to the group, but I tend to think in terms of sort of a motivating example. And so I'm not sure if we have time for this now. I can start with a motivating example here, or I can create a couple of them and have them ready for the next session. Which would you guys prefer?
Well, I guess maybe we could do a bit of both. Like if you have one quick and easy, we could discuss right now, and then we could maybe have a look at now we have 15 minutes left, so something very simple we could use right now, and then maybe for a future session we could look at a bit more detail.
Yeah, let's just take a very simple example. So the context is we have an artificial intelligence that we're building. This AI is responsible for managing a network of IoT devices in order to get a goal. So for example, maybe the goal is to make the room comfortable for, say, me. The AI would then look around, see what's in the room, and adjust these things in order to make them comfortable. Now, one of the things that it would need to be able to do is, for example, open the blinds. We want the AI to be able to send a command to blinds that have just recently been installed and to be able to open it. But we don't want to tie to a particular manufacturer or a particular device. If that open command needs to go to the door instead of the blinds, we want to be able to use SDF in a way that is generic enough that we can issue this open command with the intent of, say, lowering the temperature. But we can send this, excuse me, we can send that command to several different devices that's able to fulfill it. So maybe the blinds say, yeah, I can open in but I'm going to raise the temperature if I do that. Or the door says, well, I can open and I'll lower the temperature. The AI needs to be able to make a generic assessment and then send that command to a specific object.
Okay, thanks, Jerry. Maybe like what would be the kind of key for your use case, the key pieces of information that you would need to find, for example, I mean, you would need to be able to find blinds, for example. So you need in your system a way to say, hey, give me SDF definitions of things that are of a kind blind, and the blind being a term used in a vocabulary that your system knows about. Would that be a reasonable thing you would do?
Yeah, except it would be a little more generic than just blind, but the general idea is there, yes. There needs to be like a class of things, and then it needs to be able to communicate with that class.
Mm-hmm. Yeah. So here, what I would expect, like you would, if you look at the design on the slide, probably you would do something like look for things that have a relation. I mean, could be same as or some other term that is how you would describe what kind of things you're looking for, and then the target would match do the exact thing. Let's say, for example, blind type. And then, of course, that only works if it's a single ontology for both the types and targets used within your domain, or if the ontologies are mapped together across multiple domains. That at least would give you that piece of information. Then you would still use SDF as the generic way to describe the capabilities, but you have additional semantic hints on your system to look for.
Right. That's actually exactly what it is that we're looking for. And then we'll have, I know you guys are defining this, but devices out at the edge make that final determination to say, okay, look, this is relevant to me.
Mm-hmm. Yeah, because I think the use case you have is actually quite close to the kind of use case we have also kind of around digital twins, and the digital twin system being able to figure out what are the capabilities of the underlying devices in order to be able to build the model of a system automatically. That's the kind of use case we've been working on. For example, that's why we talk about like robot arms next to each other, because one of the cases is kind of an industrial environment with robot arms that you're trying to model. So it seems that those use cases have quite a lot of in common, at least on that step, that hey, give me devices that do, give me SDF definitions of things that are certain kind of doing certain things. And I saw Christian was asking if there's a thing the RG meeting, so and the answer is yes. But maybe
the answer was no, because it's neither a Think to Think research group meeting, it's a Wishy meeting, and nor was it not announced. It actually was announced.
yes.
So we probably have to do some email checking again.
Yeah. But I hope my reminder went out today. At least I sent one.
I got it.
Okay, so at least there has been recently surprisingly many issues with email. Okay, but then Jerry, I guess the kind of at least the basics of your use case and the kind of use case that we have in mind seem to have this type in common, that like trying to find certain definitions of objects and things and other definitions that are certain characteristics. But the key thing is like referring to external ontology. That will give you kind of the stable terms that you can talk about whatever is your domain.
Yes. If I understand your comment correctly, there is the defining of the ontology and such, but I like the comment here from Carson. I'm just looking for the proposal, the structure that says, all right, whatever your ontology happens to be, whatever the example, I'm sorry, the particulars of your data happens to be, structure it this way.
Sorry, maybe I missed a bit of your comment on the structure. Can you elaborate on that?
Yeah, I guess maybe I should say design it this way. So, for example, use SDF relations. What you see on the screen here is how SDF relations should be used. Plug in your specific data into this, what I'm calling a structure, or maybe it's just a design.
Yeah, so I guess this design would be kind of providing placeholder. You would put terms in defined elsewhere.
Right. And what I'm trying to figure out is, is this the recommended design for the use case that I just brought up? Right. It sounds like it is, but it's hard for me to, and again, maybe it's just my inexperience with this. It's hard for me to make that connection, without having a discussion. So, what I'd really like to do is be able to, not bother the group with a specific concern of mine. I'd like to be able to just go through the documentation and such and say, oh, you know what? I need to be using SDF relation for this.
Yeah, so I guess that's the kind of challenge. This is kind of one of the first initial proposals how it could potentially be done. So this is yet not at the level of like this is the way to do it. This is more of a initial proposal of a way it potentially could be accomplished.
I see. So we're still early days.
With this particular design, yes. That's
Okay.
why it would be interesting to get like a feedback on that. Like, is this a reasonable way of doing that, or are there some better ways to structure it that would be easier to use, more efficient for some way, etc. Well, what about Michael Koster? I mean, what do you think? As I said, you experimented with this approach, and you said like it kind of roughly gets done what you were also thinking of doing. But what are the things that you maybe were not a good fit? Like, what would you do differently?
I don't have any issue with this design. In fact, I think this design can actually do the 2-arm, 3-arm thing. All you have to do is just refactor it. It's really no different. So I made an example where I have an ontology I defined using this this SDF relation pattern. Can I share a slide quickly?
Sure.
Okay, let me see if I can work the mechanics of that.
Yeah, you can request the sharing from the top left.
Really? Top left? Oh, I see. Yeah. There we go. And then, oh, I just have to, wait a minute. I can only slide, wait.
Or you can request also screen share.
Huh?
You can also request screen share if you want.
Oh, this is something else. I want a screen share. Sorry. Yeah. Okay. So let me just blow this up. Do you see this then?
There. Yeah.
Is it large enough? I tried to make it full screen, but it didn't do it. It looks
just
like
a moment.
It's not. Oh, wait a minute. Let me try this other. slow. Okay. So
Okay.
what I was defined.
Sorry, Michael. It's still being started. At least I don't see your screen yet.
Oh. Okay.
Does Karsten, do you see the screen?
You might still have to confirm with your browser that you want.
I probably had to do a bunch of Google Chrome, and it's asking me if I will allow it to record my screen because I guess it's recording the meeting. Oh my God, no. I mean, I don't have,
That's the essence
I
of
can't
screen
go into my preferences and go update my preferences right now. I don't know, you know.
Okay.
It just brings up my preference, my iMac sort of preferences thing, and doesn't really tell me what to do.
Yeah. Actually, you would need to restart your browser after that, if I remember correctly. So the screen share might not work for you in the next few minutes.
I guess never mind.
Is there a link you can share, or what were you planning to show?
Well, there is, but we only have 4 minutes now. It's on my GitHub also, but it would be nice if I could share my screen. What I was going to show you was an SDF file that defines two components of an ontology and two items and their relations, both their attributes and their relations to one another. So it's a piece of equipment that has components within it. But instead of defining that as, because there are so many layers in this, instead of defining any of that as, SDF inclusion, it's all defined through the relation types, contains and part of it as and of here. And I also have target attributes. I have it relation value. I think there's some work we need to do on what we're calling the different things in the draft, and I'll make some comments about that. I think to align with what more people are expecting to see from the web linking world, which just won't change anything. But yeah, and so SDF defines these relations, and then what I wish I could show. What I've done, but I don't really want to define the instances in SDF in this case for this system. This is like the other system I'm working on. I define SDF all the way to the instance modeling level and then make instances from that. But here, I just want to use SDF to define the ontology. And then when the graph instances are made, they're just made in plain JSON. So I convert the SDF graph with all of its relations to a JSON schema that allows you to check and generate a plain JSON. But also, this is really part of my regular day job. We also generate an SQL database and do all the schema for that also from this. So it's sort of a pattern that shows the relations of SDF objects to other SDF objects. But I think I don't think it needs any new features. In other words, I think what you're defining there is functionally complete. And we just need to test it. I think what we should do going forward is, someone has a better pattern, fine, bring it forward, but let's test this against as many use cases as we can find. And consider this to be the default pattern, Jerry, and let's test it in Applied AI Studio. I'll test it in my other system that generates C++ objects for microcontrollers. We'll see if this pattern has any shortcomings for any of our use cases. I think that we should think about moving it forward.
Okay, thanks a lot, Michael. That sounds like a very good way forward. Then we have a kind of stable reference, and then we see like what are the shortcomings, and then tweak the design accordingly. So
yeah, let's make issues, comments, pull requests on the draft, and in the meantime, let's figure out what the target is for rolling it in. But I think in the meantime, we can start using it in our prototypes.
Yeah. So I guess for being able to do pull requests, we would need to put the draft in a GitHub. I guess the question is ASDF or or TinkTinkRG GitHub. it's an ASDF draft, so maybe the ASDF GitHub is the
Yeah, it's proposing a feature SDF relation that sort of is another item like SDF object and property and all of that. And I think it belongs in as an SDF, as a draft that adds a feature to SDF after the pattern we decided to try.
Yep, makes sense. So maybe let's check with the ASDF chairs if that's a reasonable way forward, and then we can take the discussion with those kind of specifics of that discussion that relate to draft in that repo, and then we can have in the future wishy calls, of course, these kind of discussions on the general design, and maybe we'll take we could consider also an ASDF interim specifically on that topic as one way to do it. But I guess the ASDF still needs to focus on getting the RFC ready. So meanwhile, wishy might be a good way for this, let's say, more explorative discussions. Good.
Yeah, at the point we'll decide it's ready for adoption, and we'll make a call for adoption, right? Isn't that how it's going to work? So we can work on it here until then. Yeah.
Yep. Okay, but that sounds very good. So let's take that as an action. And I said, Michael, let's work on the different use cases. You know, what Cherry, what have from you, what have from us, and make examples of SDF definitions using this pattern, and see how it plays out, and then come back to that and work our way from there. And I guess it would be. Oh, sorry, go ahead.
I'm sorry. I'm saying that sounds good to me.
Excellent, Cherry. And I guess like Karsten pointed out, maybe we need to take a design on the instances also early on because they are so related, and then we can refine also that design while we go. Okay, good. But now I realize we're going slightly already over time. Apologies for that, but thanks a lot for a lot of good discussions. Any final questions, comments, closing notes before we close for today? Okay, here in that case, so then the next steps. So Petri, let's check with the with Niklas and Michael Richardson, like if that's the ASDF GitHub is an appropriate thing to do. I will post it there. We can post a link to the RG list for continuing discussion specifically on the draft. And meanwhile, we work on the examples and come to those, I think, after summer vacations, maybe in the next wishy call, and take a closer look at what we have achieved. Good. So with that, thanks a lot, everyone, for joining the wishy call today. I think we made some good progress here. And see you soon again, perhaps at the IETF meetings during the Philly IETF. Personally, I won't be on site, but I'm planning to join a few sessions remotely. But then latest in the Thinking RG sessions after summer vacations towards the end of August. Okay. Thanks, everyone, and talk to you soon again.
Thank you all.
Thank you. Bye.